Hello, everyone, welcome back to the channel Future Force. Please subscribe and like my videos. This is an incredible moment of surprise, suspense, and cutting-edge military technology, all rolled into one explosive incident. Moscow in flames, 93 Ukrainian drones launch surprise attack. Picture the roar of drone engines cutting through the evening twilight as hundreds of UAV launched, a blistering swarm that stunned air defenses and set the skyline ablaze. Let's explore this event from every angle. Exterior, interior, performance, safety features, unique selling points, price connotations, and finish with a compelling conclusion. From the outside, this episode presents an arresting visual tableau. The 93 Ukrainian drones slicing into the darkened skies over Moscow create an almost surreal spectacle, fleeting points of light and contrails painting a tapestry of urgency and dramatic urgency. Each drone, compact yet lethal, is guided by precision navigation systems and sleek aerodynamic form to slice through defenses. The exterior appearance is minimalistic and functional. Smooth fuselage surfaces likely built for stealth, matte dark coatings to reduce radar signature, and slender wings for agility in packed formation flights. Tiny LED markers or reflective tips betray their position, but only briefly, highlighting both the elegance and the menace of the swarm. This visual alone evokes a formidable fusion of technology and tactics, unveiling not just a military maneuver, but a statement. Turning to what's inside, let's go deeper. Inside each drone lies a world of innovation and purpose-built engineering. At the heart is an optimized electric propulsion system, efficient brushless motors paired with high-density batteries that balance energy output with compact weight. These power plants are engineered for bursts of acceleration followed by cruising speed that keeps the formation coherent and responsive. Navigation electronics include GPS/GLONASS hybrids with fallback inertial measurement, units immused to maintain trajectory when signals falter, while collision avoidance algorithms ensure each of the 93 drones maintains optimal spacing even during aggressive maneuvers. There are onboard microcomputers running mission-specific software, flight path adherence, target acquisition, threat assessment, adaptive rerouting, and return protocols. Sensors include mini radar or LiDAR altimeters, optical flow cameras, or even infrared for low visibility flight, to maintain altitude and orientation over complex city terrain. Payload bays hide stealth, optimized warheads, shaped charges, or fragmentation devices that open only at designated points, releasing precise effects. Dozens of drones may carry high-explosive focused charges to damage infrastructure, while others carry electronic warfare packages designed to jam communications and radar arrays. The interior compartmentalization ensures that flight systems are shielded from blast and electromagnetic interference with carbon, composite casings, flexible mounts, and redundant circuitry. Thermal management systems, heat dissipating fins or mini heat pipes, keep components from overheating during rapid ascent or extended cruise phases. Communications hardware includes encrypted data links between drones and command centers, allowing real-time updates and dynamic retargeting. A small emergency beacon or pre-programmed flight home failsafe ensures lost drones can either complete their mission or self-neutralize to avoid discovery. In sum, the interior engineering represents a careful balance of stealth, autonomy, precision, survivability, and mission adaptability, making these drones not just tools, but highly specialized micro-war machines. From a performance standpoint, these drones deliver astounding capabilities. They accelerate rapidly to intercept altitude, perhaps 300-500 km/h, and maintain formation at cruise speeds while avoiding mid-air collisions. Their range likely spans dozens of kilometers, sufficient to launch from concealed positions before entering contested airspace. The swarm exhibits collective intelligence through distributed flight planning, so that if one drone is shot down, others adjust paths to maintain the overall attack integrity. Payload delivery is timed and targeted. Some reach high-priority zones like communication hubs or key energy infrastructure. Others fan out to create chaos and overload defensive systems. The performance is not just mechanical speed, but orchestration. 93 simultaneous launch, flight, targeting, and impact, like a ballet of precision weaponry. Safety features, paradoxical in a weapon system, are embedded throughout. First, fail-safe return to base or self-destruct protocols prevent wandering drones from falling into unintended hands. Collision avoidance mitigates mid-swarm accidents that could implode the mission. Secure encrypted communications reduce the risk of enemy hijacking or spoofing. Overvoltage and temperature cut-offs protect electrical systems from overheating or battery failure, which could trigger a mid-air explosion. Shielded electronics protect against explosive electromagnetic pulses (EMPs), ensuring mission-critical systems remain online during intense engagements. Even the swarm has redundancy. If certain drones fail upon launch, the rest compensate to ensure overall mission success. Unique selling points, or in this context, the defining capabilities that set this swarm apart abound. First, sheer scale and surprise. 93 drones launched at once, overwhelming air defense sensors and radars. Second, stealth engineering, radar, absorbent materials, low thermal signature, noise, muffling propulsion. Third, modular payload, capability to mix explosive and electronic warfare drones in a single mission. Fourth, AI-driven autonomous coordination, decentralized control that adapts in real time to losses or shifting defensive responses. Fifth, cost-effectiveness. Each drone might cost a fraction of traditional missiles or aircraft sorties, enabling high-volume missions with strategic impact. Sixth, mission agility. Drones can be programmed for different targets mid-flight, retasked via encrypted link, or even diverted to secondary objectives. These qualities, scale, stealth, modularity, AI, affordability, and adaptability, make this swarm not just a tactical weapon, but a strategic game changer. Now, price. While actual cost figures are rarely public, we can infer that mass-produced tactical drones of this sort are extremely cost-efficient. Unlike manned aircraft or cruise missiles costing hundreds of thousands to millions of dollars per unit, compact drones can cost thousands or tens of thousands each, easy to produce in volume, especially if using commercial components and additive manufacturing. Let's posit a rough estimate, perhaps $10, $0, $50, $0 per drone depending on complexity. Multiply by 93 and the swarm might cost $930, $0 to $4. 65 million. For comparison, traditional high-end cruise missiles may cost $1-2 million each or more. So, deploying 93 drones may still cost less than single cruise missile strike, delivering far greater combined volume, flexibility, and tactical confusion. Plus, Reusable or recoverable drones could reduce permission cost further, with components harvestable after deployment. In conclusion, this dramatic Moscow in flames, 93 Ukrainian drones launch surprise attack. Event exemplifies modern warfare's shift towards swarm tactics, autonomous weaponry, and asymmetric disruption. Exterior visuals captivate, interior technology amazes, performance overwhelms, safety features ensure mission integrity, unique selling points highlight transformative military strategy, and cost advantages underline the economic feasibility. In one breathtaking operation, the swarm redefines power projection, signaling a new era where dozens or hundreds of low-cost smart drones can deliver strategic outcomes rivaling traditional platforms. As we digest this, it's clear this is not just a strike, but a signal, weaponized innovation redefining the future battlefield.